G.9.6 Dilations. I can describe the changes occurring to the x and the y-axis of a figure after a dilation. Alright, the two vocab, your dilation and your scale factor. The dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point. Alright, so if the figure stretches, that means that the scale factor is going to be greater than 1. So stretches or gets larger, the scale factor has to be greater than 1. If it shrinks, the scale factor has to be then what? In order for it to shrink, it's going to have to be, less than 1. Looking at example 1, determine if each transformation is a dilation or not. So here's the original on the left, and here's what it turned to, the new image on the right. Does that look like it would be a small miniature image? Does it look similar to the pre-image? Yes. You know it's not congruent because it's not the same size. But is it similar? Looks like the same size and shape, the same shape, sorry. So you're telling me yes, you think it is a dilation?
Yes.
Did it shrink or enlarge?
Shrink.
So what would the scale factor be?
Less than 1.
It would have to be less than 1. So yes, it is a dilation, and it would be less than 1. And let's see if that works. So if I slide this image over here, and I shrink it, is it similar? It did work. So yes, it's a dilation, and it was less than 1. How about this image? If we were to dilate it, would it be, if it is a dilation, it would be greater than or less than 1?
Less.
It would be less than if it is a dilation. Do you think this is a dilation? Can I shrink it and get it to be like this? Are they similar? Let's vote. Who says yes? Who says no? Majority says no. Well, let's see what happens. Shrink it so it's less than 1. What would it look like? Does it look like it would be similar?
No.
No. So, not a dilation. That one does not work. It would have to look something like the blue figure there. They're not in proportion. Okay, how about this image?
Yeah.
Does this look like a dilation of the larger image? I'm saying yes. Everybody's thinking yes. Would it be greater than or less than 1?
Less than 1.
So you're saying we'd have to take this times something bigger than 1? Like 2, 3, 4, 5, 6, 7 or whatever? So let's see if it works. Looking pretty good, isn't it? Looks like I need to. Looks pretty good, doesn't it? So yes, that is a dilation and it's greater than 1. Now we get to draw our own, and I'd like you to use a straight edge when you draw the figure on your graph so you can see the comparison and they're nice and straight. So when we do a scale factor, in this one we know that our scale factor is 2. So that means the first thing we have to do is, in our pre-image, we need to find the ordered pairs of all these images, or all these ordered pairs of the coordinates. So A's coordinates are what? -4 and 4. What is B? 0 and -4. And C of the pre-image, 3 and 2. Now that we have the ordered pairs of those, we need to multiply it by our scale factor, and our scale factor is 2. So you need to multiply each and every one of these times 2, times 2, times 2, times 2. multiplying by 2 to get our new image. So A, if we take negative 4 times 2, what do we get? Negative 8, and then 4 times 2 is 8. So our new image, A prime, is going to be negative 8 and 8. What's B going to be? What's B prime going to be? The B. 0 times 2 is 0. Okay, don't let that one fool you. 0 times 2 is not 2. 0 times 2 is still 0. Negative 4 times 2 is a negative 8. C prime should now be 6 and 4. Now that we've got that, we need to go plot them on the graph and label them. Our new A prime is negative 8 and 8. Here's our new A prime. B prime is 0, negative 8. And C prime is 6, 4. And with your straight edge, let's connect our new image. See what our dilation looks like. All right, does yours match? We have a dilation, a scale factor of 2. Questions on that one? All right, let's go on to example B. What is our scale factor here? 1/2. So if you want, you can multiply by 1/2 or times 0.5. Or what is an easier way if you don't want to multiply by a fraction or a decimal. Instead of multiplying by 1/2, that's the same as what? Dividing by 2. What's the same thing as multiplying by 1/3 is the same as dividing by 3. Multiplying by 1/8 is the same as dividing by 8. All right, so remember that when you're working with your fractions here. What's the first thing I need to do? Find what? Yep, find the ordered pairs. So the ordered pair of D is negative 8, negative 4. E, the original, 2 and 6. F is 8, negative 8. Now what do I do that I have my ordered pairs of my pre-image? Then I multiply by 1/2 or divide by 2. So what is, let's work with D first. What is negative 8 divided by 2? Or cut it in half. What is it? What's negative 8 divided by 2? Negative 4. And negative 4 divided by 2 or times 1/2?
Negative 2.
Negative 2. What did you get for E? 1 and 3. What did you get for F? 4 and negative 4. Excellent. So now what's going to happen to this dilation since we multiplied it by 1/2? Is it going to get smaller or bigger?
Smaller.
All right. So plot your new one on the inside there. It should show up. Your new image should look like that. One's here, here, and here. Good match. Looks pretty good. Where do you suppose a dilation would be used in real life? I think you've probably all done it. Cameras, pictures. Some of you just did this when you made the decorations for my door. You put a picture on the dot cam and then you enlarge it. That's a dilation, so you can make the pictures bigger and copy them. All right, and this is our last one, I believe. We have 2 left. I think for time-wise, we'll just we'll stop after this one. This one has a scale. Let's see, what's the other one? Is that the other? Let's do this one. Let's do G. We'll skip C and let's go right to G. Because this one has a scale factor of 1/3, so what is it going to do? Divide by 3. Let's find our ordered pairs first. The ordered pair for my pre-image K is what?
0,
Yep, 0, -6. What's L? -3, -6. M? -6 and 3. And finally, the N is 6 and 6. So now you have to go and multiply each one of these times 1/3. Well, these all look like multiples of 3. I think I'm going to just divide by 3 to make my life easier. So what is K prime going to end up being? 0 divided by 3 is still
0,
0,
0,
and then -2. So K is 0, -2. 0, -2. And then we have the L, and my K prime. L, yep, -1, -2. Those end up being pretty close. L prime, label it. The M prime turns into, yep, -2, +1. That's now my M prime. And finally, the last one, N, 2 and 2. Label it. N prime. With your straight edge. You just created your new image, a dilation of 1/3. So, questions on that? Your homework is pages 7, 8, and 9 in the packet on dilation, pages 7, 8, and 9.